Okay, so we are learning to break apart a polynomial by its factors. So the factoring polynomials, we're going to start with what we should always look for first, which is the GCF. The GCF is the greatest common factor, what they have in common, and the greatest one at that. So just to break it down, the rules to follow. First, look at the coefficients. Look to see what is the greatest common factor of the however many coefficients there are. If they have a variable in common, they have to be in common with all of the terms in the polynomial. And if there is a variable that is in common with all of the polynomial terms, then we take the smallest exponent. And then, so once we figure out what the GCF is, then we're going to divide all the terms by the GCF to figure out what is remaining in the parentheses. So let's look at number 1, for instance. Okay, so if I look at the coefficients, 3 and 12, the greatest common factor with 3 and 12 is 3. Because 3 goes into 3 and 3 goes into 12. But I can't go higher than 3 because 3 is a small number. Nothing else goes into 3 besides 3 and 1. Now, if I look at the variables, 3 is the only one that has an x. So I can't have a variable in common here because 12 doesn't. So the GCF for number 1 is 3. So what I'm going to do now is divide both of these terms by 3. 3x divided by 3 is x, and 12 divided by 3 is positive 4. So there's my answer. And I can check my answer by redistributing. So that means distribute this 3. 3 times x is 3x, 3 times 4 is positive 12. So I end up back at the same answer I got. Number 2, if I look at 7 and 7, the greatest common factor between 7 and 7 is 7. Now, the y value, variable, is only on the first 7, so I can't bring out a y as the greatest common factor. So the only thing they have in common is 7. Now divide. 7y divided by 7 is just y, and negative 7 divided by 7 is negative 1. Again, if I were to distribute, 7 times y is 7y, and 7 times negative 7 is, or negative 1 is negative 7. Number 3, okay, the greatest common factor between 5 and 30 is 5, because 5 goes into 5 once, and 5 goes into 30 6 times. But there's nothing higher that will go into 5 and 30. Now, 5 has x and 30 has y, but they are not the same variable, so I can't bring out an x or a y. So the only greatest common factor they have is 5. 5x divided by 5 is 5x divided by 5 is x, and 30y divided by 5 is positive 6y. Okay. If I look at number 4, the greatest common factor between 8 and 36, let's see, 8 times 4 is 32, is actually 4. Because 8 does, it seems like 8 would be, but 8 does not go into 36. So other factors of 8 and 36 would have to be 2, 4, and 1. So the highest that they have in common is 4, because 4 goes into 8 twice, and 4 goes into 36 9 times. Now, with the variables, m and n are different variables, so I can't bring out a variable. So if I figure out what's left, 8m divided by 4 is 2m, and 36n divided by 4 is positive 9n. And there we go. Some more practice. If I look at number 5, 6 and 27. So greatest common factors of 6 and 27. It can't be 6 because 6 does not go into 27. So other factors could be 1, 2, 3, but 2 wouldn't work. 3 is the highest that can go both into 6 and 27. 3 goes into 6 twice, and 3 goes into 27 9 times. So if I look at the variables, I can't pull out a variable because 6 is the only one with the variable. So the greatest common factor is 3. 6a squared divided by 3 is 2a squared. And 27 divided by 3 is positive 9. Okay, if I look at number 6, Greatest common factor between 4 and 24 would have to be 4 because 4 goes into 4 once and 4 goes into 24 6 times. Now this is our first one where we can actually pull out a variable. If you look at 4 and 24, they both have a y value, okay? Now the rule is if they do have a variable in common, we can only take the smallest exponent. So this is y squared, this is y. I can only pull out one y, because I can't pull out two y's because this one has 2, but this one only has 1. So I can only pull out one y. So I'm going to bring it out. So my GCF for number 6 is 4y. So now if we divide, 4y squared divided by 4y is 1y, okay? Because I would subtract 2 and 1 to get y as 1. Then negative 24y divided by 4y is negative 6. And because the y's would cancel out. So 1y minus 6 is remaining in my parentheses. If I look at number 7, 21 and 3, the greatest common factor for those two would have to be 3, because 3 goes into 21 once and 3 goes into 3 goes into 21 7 times and 3 goes into 3 once. Now, if I look at C, D, and D, they both have the variable d in common, and the smallest d I could bring out is 1d because this one has 1 and this one has 1. So I can't pull out 2 of them or 3 of them, just 1. So then I divide. 21cd divided by 3d is 7c, okay, because those d's would cancel. And then negative 3d divided by 3d would be negative 1. 14 and 18, the greatest common factor would have to be, let's see, it's not 14 because 14 can't go into 18. The next one would have to be 7, but 7 doesn't go into 18. So 2 is actually the greatest common factor that can go into 14 and 18. 2 goes into 14 7 times and 2 goes into 18 9 times. But then I look at for a common variable, so they both have an h in common, and they both have one h in common, so I can only bring out one. So 14gh divided by 2h is 7g, and negative 18h divided by 2h would be negative 9, or minus 9. Continuing on, number 9, 15 and 30, the greatest common factor would have to be 15 because 15 goes into 15 once and 15 goes into 30 twice. So if I look at the variables, they both have a's in common, but the most I can bring out would have to be 1a because this one has 2 and this one has 1. I can't bring out 2 because this one doesn't have enough. And then I look at the b's, and they both have 1b in common. So then I look at what's remaining. 15a squared b divided by 15ab leaves me with 1a, okay? Negative 30ab divided by 15ab would have to be negative 2 because the ab's would cancel out or divide out. Number 10, 16 and 24, the greatest common factor can't be 16 because 16 doesn't go into 24, but 8 goes into 16 twice and 24 3 times. They both have a b in common, but the most b's I can bring out is 1. And they both have a c in common, but the most c's I can bring out is 1 because this one only has 1 to give. So then I look at what's remaining. 16 divided by 8 is 2. B divided by B would simplify to 1. And C squared divided by C would be just C because 2 minus 1 is 1. Plus 24 divided by 8 would be 3. B divided by B would be 1. C divided by C would be 1. So just 2C plus 3. Number 11, this one does not have a coefficient to bring out because they're both 1, but if I bring out 1, it's kind of repetitive. But they do have a variable in common. They both have an a, and the most a's I can bring out is 1. So then if I look at what's remaining, ab divided by a would be just b because those a's would cancel. Now, if I look at negative a divided by a would be minus 1 because a divided by a is 1. Number 12, There is no coefficient to bring out because it's 1 and 3. So the greatest common factor would be 1, and you don't want to bring out a 1 because it doesn't do anything to the values. They do have an x in common, but the most I can bring out is 1 because this is the only one can give. So then I look at what's remaining. X squared divided by x, I subtract, so 2 minus 1 is 1. And then 3 divided by 1 is 3. X divided by x would cancel because x divided by x is 1, and 1 times 3 is 3. And then y is remaining, so 3y. Okay, so take it up a step further. Let's get a little bit tougher here. If I look at number 13, 18 and 48. Let me see. I have to do a little bit more math there. Let's see, 18 does not go into 48, so the GCF is not 18. Other common factors or factors of 18 could be 9, but 48 divided by 9 does not work. Other common factors would have to be 6. Yep. So the greatest common factor of 18 and 48 would be 6, because 6 goes into 18 3 times and 6 goes into 48 8 times. Although there should be one more. It's not 12, 6, 7, 8, 9, 10. Nope, that's it. Okay. Yeah, that's it. So then I look at common variables. So they have an A in common, but the most I can bring out is 1A. They have a B in common. The most I can bring out is 1B. And they have C's in common, but this one's a little different because this one has 2 C's and this one has 3 C's. So I bring out the least number of C's, which is 2, because this one has 2 to give. So I do have enough to bring out 2. So then I divide it out. 18 divided by 6 is 3. A squared divided by A, I'm left with 1A. B divided by B kind of cancels out. And C squared divided by C squared kind of cancels out. So I'm left with 3A for the first remainder. Negative 48 divided by 6 is negative 8. A divided by A would simplify to 1. B divided by B would simplify to 1. C cubed divided by C squared results in 1C. So there's my remainder. Number 14, the common factor between 10 and 8, the highest I can bring out is actually just 2, because 8 does not go into 10, 4 does not go into 10, but 2 does. Then they have a common variable of x, and I can only bring out one x, and a common variable of y, and I can only bring one of those. So divide it out. 10 divided by 2 is 5. X squared divided by x is 1x, and y squared divided by y is 1y. Negative 8 divided by 2 is negative 4. X divided by x would cancel out, and y divided by y will cancel out. So there we go. Number 15, the greatest common factor between 5x and minus 13. If you look carefully, there are no factors of 5 and 13 that could result in a GCF, and they don't have a variable in common. Okay, so this one does not factor. There is no GCF in this particular problem. Now, when this happens, you can either see it written as does not factor, or we will refer to it as prime. And if you think about where that word prime comes from, there are such things called prime numbers. Prime numbers are factors that only can be multiplied by itself and 1. So that's where that comes from. So either does not factor or prime. Number 16, there are 3 terms I need to look at for this problem. So 2, 2, and 4. The greatest common factor that will go into all 3 of those numbers would be 2. 2 goes into 2 once, 2 goes into 2 once, and 2 goes into 4 twice. Then I look at variables. All 3 have an x in common, but the most x's I can bring out is 1, because these only have 1 to give. And then they also have y's in common, but the most y's I can bring out again is just 1, because these can only give 1 away. So if I look at what's remaining, 2 divided by 2 is 1. X squared divided by x is just 1x, and y divided by y is 1, but it wouldn't write it. Then negative 2 divided by 2 is negative 1. X divided by x is 1. And y squared divided by y would result in 1y. Positive 4 divided by 2 would be plus 2. X divided by x would be 1. And y divided by y would be 1. So just plus 2. You won't see your answer with 1x and 1y. It'll be just x minus y. Number 17, 3 terms again. So the greatest common factor between 6, 14, and 10. So 7 wouldn't go into all 3. 6 wouldn't go into all 3. 3 wouldn't go into all 3. The greatest common factor between 6, 14, and 10 would be 2 again. 2 goes into 6 3 times, 2 goes into 14 7 times, and 2 goes into 10 5 times. But then I look for common variables, and they all 3 have a y in common, but the least number of y's is 2. So I can actually bring out 2 of them because I can pull 2 from 4, I can pull 2 from 3, and then the most I can bring from the third one is 2. So that's the most I can bring out. So then I look at what's left. 6 divided by 2 is 3. Y to the 4th divided by y squared is y squared. 14 divided by 2 is positive 7. Y cubed divided by y squared is just y. Negative 10 divided by 2 is negative 5. And y squared divided by y squared would result in 1, so it's just minus 5. 18. The greatest common factor between 12, 36, and 6 would be 6. Because 6 would go into 12 twice, 36 6 times, and 6 1 time. Now, they all 3 have an A in common. The most A's I can bring out is 2. They do all 3 have a B in common, and the most B's I can bring out is also 2. So then I look at what's remaining. 12 divided by 6 is 2. A to the 5th divided by A squared would result in 3 A's. B squared divided by B squared would be 1, so that wouldn't be written. Negative 36 divided by 6 would be negative 6. A to the 4th divided by A squared would be A squared. B to the 3rd divided by B would just be B because 1's left. Negative 6 divided by 6 would be negative 1. A squared divided by A squared would simplify to 1. B squared divided by B squared would simplify to 1, so we're just left with minus 1. 19, the greatest common factor between 14, 28, and 14 would be 14, because 14 goes into 14 once and 28 twice. Now, this is where they try to trick me. At first, it looks like I can pull out a G, but not all 3 terms have a G in common, so I can't pull out a G. They do, however, all 3 have an H in common. So if I look at the H, the most H's I can bring out would be 1. So 14 divided by 14 is 1. G divided by nothing is G. And then H squared divided by H would be H. Positive 28 divided by 14 would be plus 2. G divided by blank would be G. And then H divided by H would simplify to 1. 14 divided by 14 would be plus 1. And H divided by H would result in 1 also. 20. The greatest common factor between 18, 24, and 36 would have to be 6, because it goes into 18 3 times, 24 4 times, and 36 6 times. They do not have all x's in common. They do not have all y's in common. This one's missing a y. But they do have z's in common. So the most number of z's that I can pull out would just be 1. So the only GCF would be 6z. 18 divided by 6 would be 3. X squared would be left, y. And then z divided by z would simplify to 1. Negative 24 divided by 6 would be negative 4. X would be left. Z squared divided by z would result in 1z. 36 divided by 6 is positive 6. I would be left with y, and z to the 3rd divided by z would be z squared. A little doozy on that one. 21. So this one does not have a numerical GCF because we have 1, 1, and 5. And I could take out the GCF of 1, but nothing's going to happen to anything inside. So let's see if they have some variables in common. They all three have an m, and the highest m I could bring out is 1, so 1m. They all three have an n, and the highest n I can bring out is also 1. So m cubed over m is m squared. N over n would simplify to 1. Negative m squared divided by m would be negative m. N squared divided by n would be n. And positive 5 divided by 1 would be plus 5. M divided by m would simplify to 1. And n cubed divided by n would be n squared. 22, 16, 28, and 8. 8 is not the GCF because 8 does not go into 28. It goes into the other two. Let's see. I guess the highest would have to be 4 because 4 goes into 16 4 times, 4 goes into 28 7 times, and 4 goes into 8 twice. They do not all three have an x, but they do all three have a y in common, and the highest y would be 1. 16 divided by 4 would be 4x, and then y squared divided by y would be y. 28 divided by 4 would be positive 7x, and then the y's would simplify to 1. Positive 8 divided by 4 would be plus 2, and then y divided by y would simplify to 1, which would just be 2 in the end. 23, 35, 20, and 15 have a GCF of 5. 5 goes into 35 7 times, 20 4 times, and 15 3 times. They do have also a variable of a in common, but the most I can bring out is 1. So 35 divided by 5 is 7. A squared over a is just 1a. Negative 20 divided by 5 is negative 4. A divided by a simplifies to 1, and I'm left with b squared. 15 divided by 5 is positive 3. A divided by a would also simplify to 1. Last one. 3, 9, and 15 have a GCF of 3. 3 goes into 3 once, 3 into 9, 3, and 3 into 15, 5. They do have an a in common, but the least number they have in common would be 1. B, the least number I can have is 2 of them. And C, the most I can bring out is 1 also. So 3 divided by 3 is 1. A cubed divided by a is a squared. B squared divided by b squared simplifies to 1. And C divided by c simplifies to 1. Negative 9 divided by 3 is negative 3. A squared divided by a is 1. And b cubed divided by b squared is b. C squared divided by c is c. Positive 15 divided by 3 is plus 5. A divided by a simplifies to 1. B to the fourth over b squared is b squared. C to the third is over c to the first is c squared. So there's my final answer.